Okay, so get ready, because today we're doing a deep dive on rocks.
Oh boy.
You sent over a stack of geology slides.
Right.
Looks like a crash course on igneous, metamorphic, and sedimentary rocks.
Yeah. Those are the big three.
Yeah, so we're going to break it all down,
Okay.
how they form, what makes them unique,
Mm-hmm.
and even some real-world examples.
Sounds good.
You might even find some in your own backyard.
Yeah, it's really interesting when you think about it.
What's that?
It's just fascinating, isn't it?
What is?
How these
Oh, yeah.
like seemingly simple stones hold clues to events that happened millions, even billions of years ago.
Yeah, no, it's true. Like
Yeah.
holding a time machine,
Mm-hmm.
but instead of a DeLorean, we have
Right.
well rocks.
Basically, yeah.
Okay, so first stop is the fiery world of igneous rocks.
Okay, so yeah, and it all starts with molten rock,
Okay.
either deep within the earth as magma
Oh.
or like bursting onto the surface as lava.
Right.
And as it cools and solidifies, it creates this incredible variety of igneous rocks
Oh, yeah, for
that
sure.
we see all around us.
Yeah, like that slide with the lava waterfall.
Oh, yeah.
That's just mesmerizing.
Yeah, it's really something.
But how does molten rock turn into so many different types of rocks?
Well, it's really a delicate dance between
Oh, yeah.
time, temperature,
Mm.
and the ingredients in the mix,
Okay.
you know?
Right.
So take granite, for instance.
Okay.
That classic speckled countertop material.
Sure.
It's formed deep underground from slow-cooling magma that's rich in silica,
Okay.
which gives it that light color and those beautiful, well-defined crystals.
Oh, okay, I see. So slower cooling means bigger crystals.
Yeah,
Makes sense.
it does.
It's like when you slowly cool sugar syrup,
Uh-huh.
you get those big rock candy crystals
Yeah,
versus regular table sugar.
exactly.
Okay.
Now compare that to basalt,
Okay.
which forms from lava that erupts onto the surface
Mm-hmm.
and cools rapidly.
Oh,
The crystals in basalt are so small, you
Right.
can barely see them,
really?
giving it a much smoother texture.
Oh, wow. Okay, interesting. And it's that rapid cooling that creates obsidian, right?
Absolutely.
That glassy black rock that looks like it came straight out of the volcano.
Yeah, like the flash frozen version of an igneous rock.
Oh, wow.
The cooling happens so fast that the atoms don't even have time to arrange themselves
Oh, wow.
into a crystalline structure, resulting in that smooth, glassy texture.
That's so cool. No wonder it was used for tools and weapons in the past.
Oh, yeah.
Talk about a sharp edge.
For sure.
So we've got these slow cooling rocks like granite forming deep underground.
Right.
And fast cooling rocks like basalt erupting onto the surface.
Exactly.
It sounds like this cooling process is a key part of the rock cycle
Yeah.
we see in this slide, right?
It is.
This continuous transformation of rocks from one type to another.
Yeah, it's a never-ending story of creation, destruction, and rebirth,
Wow.
you know? And igneous rocks are just the beginning of the journey.
Oh, wow.
Over time, they can be broken down by weathering and erosion,
Okay.
forming sediments that eventually turn into sedimentary rocks,
Hmm.
or they can be buried deep within the earth,
Ah.
subjected to intense heat and pressure, and transform into metamorphic rocks.
So it's like a giant rock recycling system,
Yeah, you could say that.
with each type of rock having the potential to transform into another.
Exactly.
And this brings us to our next stop, Metamorphic Rocks.
Uh-huh.
Talk about a dramatic makeover.
Yeah, these are rocks that have been fundamentally changed by heat, pressure, or chemical reactions.
Wow.
Imagine a piece of shale,
Okay.
a common sedimentary rock, being buried deep beneath mountains of other rocks.
Okay.
The pressure and heat gradually increase,
Hmm.
transforming the shale into slate, a harder, more durable metamorphic rock.
Like putting a lump of clay in a kiln
Yeah, like that.
and bringing it out as a beautifully glazed ceramic piece.
That's a great analogy.
Thanks.
Now imagine that same piece of slate being subjected to even more extreme heat and pressure.
Oh, wow. Okay.
Perhaps deep within a mountain range during a continental collision,
Okay.
it can transform again,
Really?
this time into gneiss.
Into what?
Gneiss. Gneiss.
Oh, nice. Okay.
It's a metamorphic rock with distinct bands of light and dark minerals.
Wow, that's crazy. It's incredible how much change these rocks can go through.
It really is.
And those bands in the gneiss.
Yeah,
That's the foliation we see in some of these slides, right?
exactly.
It looks almost like a geological layer cake.
Yeah, it does, doesn't it?
Yeah.
Foliation is a key characteristic of many metamorphic rocks,
Okay.
created by the alignment of minerals in response to pressure.
Huh, interesting.
It's a telltale sign that the rock has been squeezed and stretched,
Wow.
often deep within the Earth's crust.
So igneous rocks are born from fire, Metamorphic rocks are forged under pressure.
That's one way to put it.
What about sedimentary rocks?
Yeah.
They sound a bit calmer in comparison.
Well, don't be fooled by the name.
Oh, really?
Sedimentary rocks may form through gentler processes,
Yeah.
but they're no less fascinating.
Really?
They're the storytellers of the Earth,
Oh, wow.
preserving clues about past environments, climates, and even life forms in their layers.
It's like flipping through the pages of Earth's history book,
Yeah,
one layer at a time.
I like that.
So how did these stories get written in stone?
It starts with weathering and erosion.
Okay.
Those relentless forces that break down existing rocks into smaller pieces,
Uh-huh.
called sediments.
Okay.
These sediments can be anything from tiny clay particles to large boulders, and they get transported by wind, water, or ice,
Okay.
often over vast distances.
Like that slide showing a river carving through a canyon.
Oh, yeah.
You can practically see the rocks being broken down and carried away.
Exactly. And as these sediments are transported, they're sorted by size and weight.
Really?
The larger, heavier particles settle out first,
Mm-hmm.
while the smaller, lighter particles are carried further downstream.
It's like a giant sorting machine,
Yeah,
separating the sediments by size and density.
precisely. And eventually, all those sediments find a resting place,
Okay.
accumulating in layers at the bottom of lakes, oceans, or even deserts.
Wow.
Over time, these layers are buried under more and more sediment,
Uh-huh.
compacting the lower layers and squeezing out the water.
So it's like making a rock lasagna, with layers of different sediments piling up on top of each other.
And just like a good lasagna needs cheese to bind it all together,
Right.
sedimentary rocks need something to hold those sediment grains in place.
Oh, okay.
That's where cementation comes in.
Cementation.
Yeah. So dissolved minerals in the water seep between the sediment grains,
Okay.
crystallize, and act as a natural glue, binding the sediments together into solid rock.
Wow, that's really cool. So from fiery beginnings to intense transformations
Right.
to the slow and steady accumulation of sediments, we've covered the origins of the three main rock types.
We have.
But how do we tell them apart in the real world?
That's a great question.
If I'm out hiking and spot an interesting rock,
Yeah.
what are some clues I can look for?
Well, texture is your first clue.
Okay.
Remember how those slow-cooling igneous rocks, like granite, have those big chunky crystals?
Uh-huh.
Yeah, that's a dead giveaway that they formed deep underground.
Oh, okay.
Geologists call those intrusive igneous rocks.
Intrusive igneous rocks.
Like they're intruding on the Earth's personal space.
Intruding, I like it.
Yeah.
So if I see a rock with crystals, I could practically mistake for gemstones.
Right.
That's probably an intrusive igneous rock.
Most likely.
Okay.
Now, on the flip side, if a rock has a very fine-grained texture,
Yeah.
almost smooth,
Uh-huh.
it's likely an extrusive igneous rock,
Extrusive.
formed from lava that cooled quickly on the surface.
Okay.
Basalt, with its dark, sleek appearance.
Right.
That's a perfect example.
So big crystals, deep underground.
Yeah.
Small crystals, surface eruption. Got it.
Okay.
But what about those metamorphic makeovers?
Yeah.
How do I spot a rock that's been through the geological ringer?
Well, look for the signs of transformation.
Okay.
Has the rock been stretched, squeezed, or folded?
Uh-huh.
Those wavy patterns or foliation
Yeah.
are a classic sign of metamorphism.
Okay.
Think of it like this. Imagine putting a stack of colorful papers
Okay.
under a heavy book.
Mm-hmm.
The pressure would cause the colors to blend and create these really interesting patterns.
It's like those beautiful bands of minerals we saw on the gneiss slide.
Exactly. So
Okay.
foliation equals metamorphism.
Foliation equals metamorphism.
Right. Okay, cool. Are there any other telltale signs?
Yeah. Are they where?
Yeah. Keep an eye out for any unusual mineral combinations. Metamorphism can create minerals that wouldn't normally be found together
Oh, wow.
in other rock types.
Really?
It's like taking a bunch of different ingredients,
Okay.
throwing them in a pressure cooker. You never know what kind of exotic dish you might end up with.
That's intriguing.
Yeah.
So metamorphic rocks are the rebels of the rock world,
You could say that.
breaking the rules and forging their own path.
Yeah.
But what about those sedimentary storytellers?
Yeah, sedimentary rocks.
How do their stories unfold?
Sedimentary rocks. They're like time capsules.
Really?
Preserving bits and pieces of Earth's history in their layers.
Wow.
One of the easiest ways to spot them is to look for well layers.
Layers, okay.
Those distinct bands of different colored or textured sediments
Right.
are a dead giveaway.
Like the Grand Canyon. With its majestic layers of rock, Stretching back millions of years.
Millions of years.
Wow.
Yeah,
So layers equal sedimentary rocks.
basically. Yeah.
Makes sense. What other secrets are hidden in those layers?
Fossils.
Fossils. Oh, wow.
Sedimentary rocks are the primary rock type where we find fossils,
Okay.
those preserved remains of ancient life.
Okay.
It's like finding a dinosaur bone in your backyard,
Oh, wow.
a tangible link to a time long ago.
Wow. So each fossil is like a little window into the past,
Yeah,
revealing the creatures that once roamed the earth.
exactly.
It's incredible to think that something as simple as a rock can hold so much history.
It is. It's amazing.
Yeah.
And don't forget about those fascinating sedimentary structures.
Oh, yeah. What are those?
Ripple marks, mud cracks, cross-bedding. They all tell a story about the environment in which the sediment was deposited.
That's like being a detective,
It is.
using these clues to piece together the puzzle of the past.
Yeah.
You mentioned ripple marks.
Yeah.
Is that what it sounds like?
Yes.
Like tiny waves frozen in stone?
Exactly. Wow. Imagine standing on a beach, watching the waves gently lap at the shore,
Okay.
creating those beautiful rippling patterns in the sand.
Yeah.
Now imagine that sand being buried, compacted, and cemented into rock,
Wow.
preserving those ripple marks for millions of years.
Oh, my God.
That's the power of sedimentary rocks. They capture these fleeting moments in Earth's history
Wow.
and turn them into lasting records.
So from towering mountains to vast deserts to ancient seafloors,
Yeah,
sedimentary rocks paint a vivid picture of our planet's past.
they really do.
We've covered how to spot each rock type,
We have.
but I'm curious,
Mhm.
how does this constant transformation of rocks,
Mhm.
this rock cycle we keep coming back to, actually happen?
Right.
It's one thing to see it on a slide,
Uh,
but what are the driving forces behind it all?
Well, it's a delicate dance between two main players.
Okay.
Internal forces deep within the Earth
Okay.
and external forces shaping the surface.
Okay.
Think of it like a geological tug of war, with rocks caught in the middle.
A geological tug of war.
Right.
I like that. So what are these mighty forces?
Well, let's start deep underground with the internal forces.
Okay.
Imagine the Earth's core,
Okay.
a fireball of molten iron
Right.
generating immense heat that radiates outward.
Okay.
This heat, combined with the pressure of overlying rocks,
Mm-hmm.
can partially melt rocks. Oh, wow.
Deep within the Earth's crust.
Okay. Creating magma.
So it's like a giant underground furnace,
Yeah,
melting rocks into that molten goo we call magma.
basically. Yeah.
And that magma is what eventually leads to those impressive igneous rocks we
Mhm.
talked about earlier.
Mm-hmm.
But what about those external forces shaping the surface?
Sure.
Those sound a bit less intense,
Yeah.
but I bet they pack a punch in their own right.
Absolutely.
How
Think about the power of a rushing river,
Okay.
carving its way through solid rock,
Right.
or the relentless pounding of ocean waves against a coastline,
Oh, yeah.
or even the slow but steady grinding of a glacier.
Wow.
These are the external forces of weathering and erosion,
Okay.
constantly reshaping the Earth's surface.
It's amazing how something as seemingly gentle as a flowing river
I know, right?
can have such a dramatic impact over time.
Yeah.
It's like saying water always finds a way.
Precisely. And as these external forces break down rocks,
Right.
they create the raw materials for sedimentary rocks.
Okay.
Those tiny fragments of rock we call sediment.
Right.
And that sediment gets carried away by wind, water, or ice,
Okay.
eventually settling down in a new location, like a giant geological jigsaw puzzle constantly being assembled and reassembled.
That's a cool visual.
Yeah.
And those sediment layers, compacted and cemented together over time, form those fascinating sedimentary rocks that tell us so much about Earth's past.
Exactly.
But it sounds like there's a constant interplay
Yeah,
between these internal and external forces.
there is.
It's not just one or the other.
You've hit the nail on the head.
Okay.
It's a dynamic dance between creation and destruction,
Wow.
uplift and erosion,
Okay.
burial and exposure.
Wow.
Mountains are thrust upward by tectonic forces,
Right.
only to be slowly worn down by weathering and erosion.
Oh, wow.
Volcanoes erupt,
Mm.
spewing out lava that cools into new rock,
Okay.
which is then broken down and recycled into the system.
So it's like a giant geological recycling system
It really is, yeah.
with rocks constantly being transformed from one type to another.
Exactly.
And this cycle has been going on for billions of years,
Billions of years.
shaping the planet we know today.
And it's still happening
Really?
right now,
Wow.
all around us, even though we might not always notice it.
That's wild.
The next time you see a pebble on the ground,
Okay.
imagine the incredible journey it's been on.
Oh, wow.
Perhaps starting as molten rock deep within the earth,
Wow.
then being uplifted, weathered, eroded,
Wow.
transported, deposited, and finally cemented
Wow.
into that unassuming pebble.
It's a humbling thought, isn't it?
It really is.
It really is. It makes you appreciate the power of geological time
Yeah,
and the interconnectedness of all these processes.
absolutely.
Well, I have to say, this deep dive into geology has been absolutely fascinating.
It's really cool stuff.
We've uncovered the secrets of the three main rock types,
Yeah.
explored the forces that drive the rock cycle, and even learned how to decipher the clues hidden in every rock we encounter.
It's like being a rock detective.
Yeah.
Yeah.
So to our listeners, we encourage you to get out there and explore the geological wonders in your own backyard.
You can go on a rock hunt.
Pick up a rock, examine its texture, its color, its layers.
Have fun with it.
Imagine the forces that shaped it,
Right.
the journey it's been on.
Absolutely.
You might just be holding a piece of Earth's history in your hand.
That's right.
Well, thanks so much for joining us on this rock-solid deep dive.
Oh, it's been my pleasure.
Until next time, happy rock hounding.